All right. This video, I'm gonna be going over the idea of vector independence and the symmetry of free fall, the symmetry of free fall and vector independence. And the idea of vector independence is just that things can be separated into a y-axis, all right, and an x-axis. Right? There's a y, x, and a y. And things that go in this direction, go this way, this way, this way, they all have a y or an x-axis. Y or an x-axis. Let's take a look at this GIF to the right. All right, I mean to the left rather, and you see that the launcher is launching. Well, the launcher is moving to the right. Right, the launcher is moving to the right, so you have a velocity in the x direction. You have velocity in the x direction. What happens in the middle of that is that the launcher is launching a projectile straight up, right? So at some point in time, at some point in time, your your launcher gives a velocity in the y direction to this projectile, to this ball. So now once the ball is in the air, leaves the canyon, the ball has a velocity in the y direction and a velocity in the x direction. And when you combine these two parts, well, then you're going to get a parabola, right? That's what they call it in math. You get a parabola. And so at every single point in time of this object, there's a velocity in the y direction, and there's a velocity in the x direction. All right? Velocity in the y and a velocity in the x direction. And on this side, velocity in the y direction is now going down, and the velocity in the x direction. So this is the idea of vector independence. And these don't really mix. They don't mix because, well, let's take a look at vectors, vector addition, right? So let's say I have a vector of 100 meters per second, 100 meters per second, and a vector, another vector here, and let's say that's like 50. Well, that's sure, 50. 50 meters per second. And this is the, let's say this is the velocity of a plane. Velocity of, actually instead of a plane, let's say boats. Let's say a boat, velocity of a boat. And this is the velocity of the current being the water current, velocity of the current. And so when you add both of these vectors together, you're going to get that vector, right? And you add on that vector, and you get 150 meters per second, right, in the south direction. But this is in the vertical direction. But this is only true if they're both acting in the vertical direction. I can only do this if they both act in the vertical direction. I'm doing 100 plus 50. But let's say instead of both of these vectors acting in the vertical direction, that's my boat velocity, and let's say the velocity of the current is this way. And so there's 50 meters per second in x direction from water current, and 100 meters per second in the y direction, which is the boat's velocity, And so you can't really just simply add both vectors now. One vector is acting in the x direction, the other vector is acting in the y direction. All right. So, but then what's the path of the boat? Well, if the boat is going straight vertically, and then the water current is pushing the boat to the left, well, then your boat is going to make a path this way. That's a path of the boat. This is the path of the boat, right? And similarly, if you don't really understand this, let's say you're pushing a table. Someone is pushing this way. Another person is pushing this way. Well, which direction is the table going to go? The table is going to go this way. table is gonna go this way. All right, that's the direction of the table. That's the direction of the table. And so that's what's happening right here, right? That's what's happening right here. It's the same exact situation, just really with uh different objects, right? Different objects and forces. That's basically what that's in. This is gonna be force in the y direction, this force in the x direction, this is the total force applied. That's the total force applied. And so that is vector independence. The idea of x and y vectors do not mix. They cannot mix. They cannot mix. They cannot mix. And well, how do we solve this? Well, we use the Pythagorean theorem, a squared. Well, that's not a squared yet, it's just a. This is a, and this a squared plus b squared is c squared. And that's how you would solve for. That's how you solve for the side right there. That total resultant vector. That resultant vector. Resultant vector.